the solution of the problem of the battery born in the designer, in the idea of the battery. The solution is the form of the batteries, the distribution, and the logistics on the return this device. Action is return the batteries to the industry.
Well, we are a developing country, and we have no solutions here for this kind of problem. We used to discard our batteries, which is a huge problem here, and we are trying to pass laws to make the manufacturers responsible for those batteries.
Well, I would say in general, first of all, a safe battery. Secondly, one that is, when properly managed, can be recyclable. Thirdly, insofar as possible, from materials that are not so scarce that the price goes crazy. I like for it to be durable. I like for it to be rechargeable. And I like for it, then ultimately, yes, recyclable. One final type of battery that we are also having increasingly, and that's to help us to accelerate the transition to the equitable, sustainable, livable post-fossil carbon societies, is to have batteries to store electricity from solar energy powered and wind energy, and similarly to use those same kinds of batteries as backup power, say for hospitals and other emergency needs, instead of having diesel powered generators.
In terms of the future of battery, I'm really annoyed by having all these different batteries and trying to figure out how to charge them and dispose them in an environmentally friendly way. So ideally for me, in the future I would have a battery that would fit all my gadgets I have, or ideally even I could use it like the cloud or the internet to charge my devices remotely. Of course, without the electromagnetic pollution that might come with it.
What are the implications of connection to the kinds of, and the way we manage energy now, and the way we, let's say, transform energy into movement, basically? It takes a sort of, from, let's say, a mechanical reaction, oxygen with a combustible, so you have a sort of a wave that goes in this form, so exponentially decreasing. If we could think of processes to accumulate, let's say passively, the energy and then release it in this way, it's a complete opposite. That would revolutionize, let's say, energy management and usage.
Batteries, why do we need batteries? As we move to a sustainable world, batteries are becoming increasingly important because we need to electrify our energy system. But in order to really truly get there, batteries need to move forward in a number of ways. Probably the most significant one is that we're able to reuse the batteries over and over again. That means that they can be more easily recycled without releasing toxics, so that the batteries are benign ecologically. Probably also it would be good if they can have more cycles, so they don't have to be replaced that often and rebuilt, because now that's a limiting factor for many batteries. And of course energy density, because if you want to have more mobile applications like using electric bicycles, more mobility with electricity, the weight of batteries obviously plays a big role.
We should kind of stop focusing on super everlasting batteries and kind of start curing our addiction to be, always connected with our smartphone. So I guess that the lasting of the batteries is not the main characteristic for me to achieve in future batteries. It would be much more important for them to be clean, to be recyclable, and mainly to be produced in a more transparent way, from the cradle to the grave. And it would be nice if there would be a way to be sure that the minerals and the fabrication of the battery in general is traceable.
Hi, my name is Isabel. I'm from São Paulo, Brazil, and I'm studying urban parks in São Paulo. And I believe the challenge is to make people understand the importance of not being dependent on fossil fuels energy.
So the main goal of my project is to develop a small-scale redox flow battery that could be used in electronic applications, basically to miniaturize the device. So at the moment we are looking at different redox couples, different solvent systems that can be safely used in these sort of batteries, which is safe to be applied in electronics altogether.
The project I'm working in ASIS is sodium air batteries, which is a new type of metal air batteries. So compared with the conventional energy battery technologies like lithium-ion batteries and sodium-ion batteries, metal air batteries show promising performance due to its high theoretical energy densities, and in particular for the sodium air batteries recently attract a lot of attention. Compared with the well-known lithium oxygen batteries, sodium oxygen batteries show promising performance. For example, it has high energy, high over potentials, and better cycling abilities. And the most important, the sodium compared with lithium is cheaper, and it will have large abundance of sodium in nature.
A lot of our research is built around the idea of trying to look at replacements or the next solution to the current lithium-ion technology. For the future of, I guess, advanced battery technologies, the way I view it is there's two key areas of development that are needed. One is for small and portable, including up to electric vehicles, so no longer small at that stage, but where the energy density is really critical, so where we've got to reduce the weight and size of the current lithium-ion technology, which is the current best technology in terms of lightweight. Some of our research focuses towards sodium-based technologies as a replacement for lithium, where sodium being a much more abundant element. Another way to reduce cost is to look at the durability of the battery, so how many cycle lives, how long do they last under a given duty. Now this is particularly important for something such as a large-scale battery. So the future of batteries, we will see the onset of these technologies. So our research for high energy batteries, we're looking at in particular metal-based electrodes, so replacing the current graphite electrodes that are used in lithium-ion technologies with metal, which is a much higher energy, much higher what's referred to as specific capacity, so the amount of charge per gram of material is around 10 times higher for a metal battery compared to a graphite-based cell. We are mainly focusing on lithium and sodium. In our research, we've also looked at magnesium and aluminium, and all these are possible. Each of them has their difficulties in making them work. All of our research starts from a premise of looking at safe materials or trying to improve the safety of batteries.